Hey guys, it's Miss Baker. Today we're going to start off our physics on page 100, Metric System Basics. Okay, so what do you think this first map indicates? Okay, we've got the United States, Liberia, and Myanmar. I think that's how you say it. Not entirely sure. Well, what this map indicates is the only three countries in the world that still uses the English system of measurement using inches, miles, and all of that kind of stuff. Okay? There are only three countries in the world. The rest of the countries all over the world use metric system. Okay? These base units use prefixes added onto the bases, and it shows them units of tens. Okay, we got the kilometer, the hectometer, the decameter, the decimeter, the centimeter, or the millimeter. Okay, so how this works, let me go back one. How this works is you are moving your decimal over to the left or right for each stepping stone. So I wanted you to think about that you are trying to get across the river, okay? And that your significant, hold on, let me get the pen going. You are on, let's say, your base. Your base is always the meters, the grams, or the liters. So you are sitting right on this stone. Now you want to go from meters, let's say we're going to go to from meters, which is a base, to a kilometer. So you want to go to right here. Your significant other is here. Okay, sig other. Now, that means your boyfriend or your girlfriend. Okay? Now, get this off. Now, what you need to do is figure out how many steps and in what direction does it take you to get there. So you are sitting right here. You're going to go 1, 2, 3 steps to the left direction. So let's say you have 1,000 meters, and we want to know how many kilometers that is. So your decimal point is right here. And what we're going to do is we are going to move this decimal. 1, 2, 3, and then make that your decimal point right there. So that is 1.0 kilometers. Okay? So let's try that. Let's clean this up. Give me a second here, guys. Now let's try something else on this one. Let's try doing something a little bit different. Let's say we were going with 53 grams, and we want to know how many milligrams 53 grams is. Okay, so we've got grams. This is U, is in grams, and your significant other, your SO, is in milligrams. Okay, so how many steps does it take? So we're right here, 1, 2, 3 steps to the left. So 53, your inferred decimal is right here. So we're going to go 1, 2, 3. Push your decimal on the outside in the same direction you were moving. And this is what I call filling in Easter eggs. So we're going to just do this. So that was 53,000 milligrams. Okay. Let's do another one. Let me erase this. Okay. And we're going to try another one. I think the yellow is the one. Let's go from deciliter to decaliter. So we're going to say 93.5 deciliter, and then we want to go to DAL, decaliter. Okay. My eraser. I've lost my eraser again. Let's get this so it's nice and clean. And okay. So you are right here. How many steps? 1, 2 to the left. So it is 93.5. We're going to move this 1, 2. So it is 90.9. Oh, my pen's going crazy. 0.935 decaliter. Deciliter, sorry. Decaliter. Decaliter's right. Okay. So you're just, where are you? Where do you want to go? How many steps does it take? And do you move your decimal to the left or the right? And always remember, if it's like 103, your decimal point is always on the right-hand side. Okay? And you're just going to move it. Even if there's no decimal point, the decimal point is always on that side. All right? So let me clear this. Okay, so on this next page, what we're going to do is practice working our way back and forth over the metric system. So, do my favorite purple. All right, so now we need yellow on this one. All right, so we're going to talk about 32 DG, which is this one. This is you. And you want to go to grams, which is your significant other. All right, so how many steps does it take? 1 step to the left. So we've got 32. Your decimal point is right here. So you're going to do 1 step to the left. So it is 3.2 grams. Okay, so let's try something maybe a little bit harder. Let's look at number 8. Okay, number 8 is 6HL. HL is right here. And then we want to go to liters. So you are here. Your significant other is here. We're going to go 2 steps to the left. So you've got 6. You got your decimal point here. You're going to go 2 steps to the left, put the decimal point, and then close in your Easter eggs. So you have 600 liters. Okay? All right. So I think that's really all you need for that. So I'm going to move on. Okay. So this next thing we're going to talk about is describing matter. Matter is described in 2 ways. We have qualitative, which means describing without numbers. It's color, shape, smell, taste, sound, or feel. Versus quantitative. Quantitative is its description using numbers: mass, height, speed, velocity, acceleration, volume. The big deal to remember on this one is it must contain a unit. Okay, it's got to contain a number and a unit. Okay, so what you're going to do is what we are going to do is you are going to describe me to your best friend. Okay, you're going to describe something about me, and I'm going to give you some things to start off with. So, a qualitative observation is I am a girl. Okay? A quantitative observation, remember quantitative has to do with numbers, is I am 51 years old. Okay? I might be 52 or 53 or 54 by the time you guys watch this. But right now, at this moment, I'm 51 years old. I have brown hair. Brown is a descriptor, so that is qualitative. I have brown hair. And I have some gray with gray. Okay, I call that my unicorn sprinkles. All right. I have two hands, a left hand and a right hand. I am currently wearing a gray hoodie. Okay. I have two socks. Two socks is a quantitative. So two socks. Okay, so what I would like you to do is I would like you to come up with your own qualitative and quantitative observations about me. Just be nice, please. Okay, physics use two different types of measurements when we're dealing with it, and those measurements are going to be quantitative data. All right, the first one is a direct measurement. This is a measurement that uses tools. Okay, an indirect measurement is a mathematical calculation using direct measurements in an equation to find some kind of relationship. Now, we're going to spend the next 6 weeks working on both direct and indirect measurements. We're going to practice direct measurements today and then for the next few days, and then the majority of everything else is going to be some version of indirect measurements. But don't panic, it's not hard, it's just add, subtract, multiply, and divide. Okay, so the metric system uses 7 direct measurements. You've got length. Length, the tool that you use is a ruler. The unit that you use is some version of meter, and the symbol is M. Mass, the tool that you use to measure is a balance. The unit is a gram, and the symbol is G. Volume, the tool we usually use to measure volume is a graduated cylinder. It is liters or centimeters cubed, and usually the symbol is L or cm cubed. Time is measured with the tool that is a stopwatch or a clock or a cell phone timer, something like that. The unit is usually seconds, but it can be minutes, it can be hours, it can be days, years, centuries, epochs, eons, it can be all sorts of things. The symbols, again, usually seconds or minutes, S or MIN. Temperature is measured using a thermometer. It is usually in Celsius, but it could be in Kelvin. The symbol is K or C. Electric current is an ammeter. It is measured in units of amperes, and the symbol is A. Okay, I think this last one is talking about light. Light is measured with a photometer. Its unit is candelabras, and it is CD. I have no idea how to actually say that word. I've never heard it said. Okay? Now, distance is always measured using some version of meters. Never, ever use inches, feet, or miles in science. Remember, the idea of science is to communicate all over the world. We should have a central use of measurement. The entire world uses the metric system. In these terms, we will always use the metric system. So if you ask me, Miss Baker, are we supposed to measure in inches or centimeters? I'm not going to answer that question for you. You are always going to use either centimeters or millimeters or meters. You will never use inches. All right, so your next job is you are going to measure a variety of objects. You are going to, first of all, measure them in centimeters, and then you are going to convert them into millimeters. So your height is you standing up straight from your heel where it hits the ground to the top of your head. Arm span, put your arms out to your sides, straight out, and you're going to measure the tip of your birdie finger to the tip of your other birdie finger, straight out. Your forearm is from the wrist to the inside of your elbow. Your foot is from heel to toe. Your neck is all the way around. Your waist is all the way around. The width of your thumb is the fat part of your thumb. The length of your pointer finger is the length of your pointing finger, and the length of your pencil is the length of whatever writing utensil you currently have. Now, the next 6 measurements you're going to take are objects of your choice. Please keep it clean and appropriate. I don't want to know some of your measurements. Please don't share those with me. Okay, temperature is usually used with the Celsius scale, and it could be used with Kelvin. Now, the difference between the Celsius scale and the Kelvin scale is scientists don't like using negatives. So the Celsius scale was the French's idea, the French, like the country France, who developed the metric system. What they used on temperature was 100 degrees is pure water boiling. 0 degrees is pure water freezing. Anything below 0 degrees Celsius became negative numbers. Again, scientists don't like negative numbers. So what they decided to do was to create a new scale. And that was absolute zero. That is the temperature of space, which is minus 273 degrees Celsius. They made that 0 degrees Kelvin. So they went up 1 degree Celsius for each step upwards. So to find the Kelvin, what you do is you take your Celsius plus 273 degrees. If you have a Kelvin temperature, you take the Kelvin temperature minus 273 degrees. Okay, this next one is, what is mass? Mass is different than weight. Weight changes based on the gravitational pull between the object and its elevation or the planet. Weight is mass times gravity. Mass is how heavy an object is. It is measured using a balance, and the units are grams. Okay, mass does not change from planet to planet, but weight does. Okay, you can watch this video. We will watch it in class if you don't watch it. Okay, so this is what's called a triple beam balance. This is a balance, and you have a pan which you put your object in that you want to find the mass, and then you have riders. We call these masses also, but right now I'm just going to call them riders. Okay, and then you have your pointer. Your pointer needs to be at 0. So what you do is you put your object on right here, and you find your biggest rider, and you move it, and there are little little notches in here, you have to keep it in the notch correctly. You're going to move it until your pointer drops below 0, and then you slide it backwards 1. Okay, so you do that with your hundreds first. And then you do the same thing with your tens. You move it until the pointer drops down, and then move it back 1. And then when you get into the ones, you slide it until this pointer points exactly at that triangle. Then you're going to say this plus this rider, the hundreds rider, plus the 10 rider, plus the 1 rider equals the mass. Okay? So we are going to do this one together. So this is 100 plus 40 plus 2. This is going to be 142 grams. Number 2, 200 plus 40 plus 4, 244 grams. Number 3, there is no hundreds, so 0 plus 40 plus 3, so this one is 43 grams. Number 4, 500 plus 40 plus 5, which is 545. And then when this rider is in the middle, you have to count the notches. You say point, so 545.1.2. So this is 545.2. This one has the hundreds rider in the center, so this is 722.9. You see how there's 9 marks in between here? So this is 722.9. On this last one right here, you've got 0 plus 20 plus 7. So this is 27.567. So this is 27.7. All right, now this is an electronic balance. All right. When you are looking at this, all of them are about the same. They all have an on-off button. They all have a unit button. And they all have a tare button. It might either say tare or 0. That is how you balance out. So the first thing you do is turn your balance on. Then you make sure your units say grams. Then with nothing on it, make sure this pan right here is empty. You're going to push the tare button. That will make this 0. Okay? Then when you put your object on it, you know you are just finding the mass of the object. And that will pop up right here, and that's where you take that information. All right. This is an activity that this next one is an activity that we are going to do in class. So don't worry about this one. All right. We're going to do this in class too, so we're going to continue that one. All right, what is volume? Volume is how much space matter takes up. It can be measured in 2 ways. If you've got an object that is very uniform, it is square or it's circular, it's a cube, it's a triangle, but it's very, very consistent. You can take the height times the length times the width, or whatever math way to figure out whatever that object is. Or if the object is waterproof, like the majority of our objects are going to be, you're going to use water displacement. So if the object is waterproof, submerge the object in water and see how much the water level increases. This is the object's volume. So in this example, The water level is right at 30. That is our volume initial, V subscript I. Y'all know what subscripts mean. So then what we did is we put a rock in the same water, and the water rose to 40. So VI equals 30 milliliters, and this would be VF, the volume final, equals 40 milliliters. All right, so what you're going to do is take the volume final, VF, minus VI, and that tells you the volume of the rock. So 40 minus 30 equals 10 milliliters. All right, so the volume of the rock is 10 milliliters. Always circle your correct answer, please. Okay, when you're looking in a graduated cylinder or any kind of graduated cylinder, hold on, guys. Any kind of graduated cylinder, and you've got liquid in there, you will notice that liquid always rises up on the sides. It creates this curved appearance, okay? That is called the meniscus. You need to make sure that you are reading the bottom of the meniscus, okay? Make sure you're looking at it at eye level. The meniscus or the graduated cylinder is on a flat table. You are not holding it. You are looking at it right on eye level. And you are always going to read at the bottom of the meniscus right here. Do not read on the upper side. You're going to read right at the bottom of the meniscus. So this, on this first graduated cylinder, it is going to be 35 milliliters. Although the sides show 36, you are reading at the bottom. We know water creeps up, so we've built all these graduated cylinders to show this. Okay, displacement can measure the volume of an irregular solid. So we've just done this one. Water, here's the idea, that two objects cannot be in the same space at the same time. So when we put a rock in water, that water will raise up the same volume as the rock does. That rock is going to push the water out of its way. That pushed water will rise up the same exact volume as the rock is. All right? So, when we're looking on this one, our initial volume our VI equals 30, 31, 32 milliliters. Our final volume is 30, 31, 32, 33, 34, 35, 36, 37, 38. VF equals 38. We could take VF, 38, minus VI, which is 32, which equals 6 milliliters. The goldfish is 6 milliliters. Okay, so the man here, okay, so we've got 1, 2, 3, 4 in between 3 and 4. So these are all 0.2. So this is 3, 3.2, 3.4 are, sorry guys, my VI equals 3.4. We're assuming milliliters. And then when we put our little man in here, it comes up to our VF equals 5.0 milliliters. So we're going to say VF is 5.0 minus 3.4, 4.4. So that would be 1.6 milliliters is the man's volume. Okay, so I think you guys can get through this. Okay, guys, so this is the last of today's video. I hope you enjoyed it. I hope it makes sense. And have a great day.